Hi everyone, I'm Gil, a developer and JavaScript teacher here at Treehouse. I'm really excited to teach you the basics of JavaScript. JavaScript is a great first programming language to learn. It's fun, versatile, and you can use it in any web browser, which means that you can get up and running doing useful things right away. JavaScript started life as a simple scripting language and tended to add engaging interactive features to web pages. However, JavaScript's grown into a powerful general-purpose programming language that's used on nearly every website in the world and in all phases of development, from software to hardware, making it one of the most in-demand developer skills. So it's a great time to be learning JavaScript. Let me take you through some of the places you can find JavaScript, then we'll jump into a quick programming example.
Developers have always used JavaScript to add fun and useful features to web pages. The most common place you'll encounter JavaScript is on the web, where it's used to create everything from engaging photo and video galleries, like a pop-up or scrolling gallery, to complex animated experiences, like this interactive photo gallery shaped like a disco ball. With JavaScript, you can create immersive web experiences and make ordinary web experiences like signing up at a site and filling in a form more exciting and delightful. You can even make games using HTML, CSS, and JavaScript, like in these examples. Developers use JavaScript for more than just adding visual flair to a website. Many of the world's top websites and apps use JavaScript for useful functionality. For instance, web applications like Google Maps, Gmail, and Google Docs depend on JavaScript. Many tasks, like creating a new email or document, titling a document, and adding numbers and calculations to a spreadsheet, for example, are done using JavaScript. One of the best parts about getting started with JavaScript is that because it's implemented in a web browser, you don't need additional tools or setup to get going. Let me show you a fun example. In fact, you can code along if you'd like by launching the workspace with this video. In the workspace, open the preview.js file located inside the JS folder. Don't worry about what any of the code in this file means right now. You'll learn more about what each part of this code does and have a chance to do lots of programming with JavaScript throughout the course. This is a JavaScript file containing a short program that asks the user by name, "Hi, want to see something cool?" Then it replaces all the content on whatever web page they're visiting with a welcome headline and an animated GIF. First, I'll replace the text inside these quotes with my name. And now I'll run this script in the browser. In fact, I'll try it on a live website. A quick and easy way to run JavaScript is in the web browser's developer tools, using a tool called the JavaScript console. One way to open the console is with the keyboard shortcut Command-Option-J on a Mac or Control-Shift-J on Windows. You're going to use the console all throughout the course to run and test JavaScript code, identify and fix errors, as well as display messages from within your program. The console lets you interact with the web page you're currently on, so I can try this script on just about any website by pasting this code into the console. For instance, I'll run the script on the MDN WebDocs site, which is one of the best resources on web technologies, just for fun. I'll copy all the code from my file and paste it into the console, then press Enter or Return. We see a dialog box pop up on the page that says, "Hi Gil, want to see something cool?" When I click OK, everything on the page disappears. The web page's HTML, CSS, and JavaScript is replaced by the headline and an image. And notice that this is only temporary. When you refresh the browser, everything comes back. I can make this script a little more useful and interactive by allowing any user to enter their name into an input field and display it on the page. I'll replace my name inside quotes with prompt and the message, "What is your name?" And let's see what this does. I'll copy my updated code, then paste the code into the console and press Enter. Now a dialog box appears that asks, "What is your name?" I'll enter Gil and click OK. And now the alert dialog says, "Hi Gil, want to see something cool?" When I click OK, Again, everything on the MDN docs page disappears and gets replaced by the welcome headline and GIF. Neat. This is another advantage of learning JavaScript as your first programming language. You can get instant feedback in the browser with a minimal amount of JavaScript code. I'll refresh the page. Now all the content is back.
JavaScript isn't just limited to the web browser. You can also use JavaScript outside of the browser, even on web servers. For example, Node.js is a popular choice for writing JavaScript that runs on the server. Node offers great performance and easily handles lots of simultaneous users. It's a favorite of big companies like PayPal, LinkedIn, and Netflix, who use Node to serve up at least some portion of their websites. There are even complete desktop applications written in JavaScript. For example, Slack, GitHub Desktop, the Visual Studio Code Editor, and Discord are all written with JavaScript. You'll learn a whole lot more about Node.js in later courses, and you'll need to study a lot and work hard to build the next Slack or Discord. But the basics you're going to learn in this course will provide the foundations for building complex user interfaces and software that's usable by everyone on just about any device. And with just the basics, you can start using JavaScript in all sorts of fascinating and meaningful ways. If JavaScript is your first programming language, I bet you're excited, but also maybe a little nervous and not sure what to expect. That's natural. I too felt a bit intimidated and out of my comfort zone when I first started learning JavaScript. There were a lot of new terms and concepts introduced. It wasn't until I fully immersed myself in the language that I started to pick up quite a bit. Concepts began to stick, and code looked more and more familiar over time. So this JavaScript Basics course, along with other follow-along courses, is intended to guide you and help get you immersed in the JavaScript language with quizzes, code challenges, practice opportunities, and more. It's going to be challenging, but also awesome and rewarding. I'm excited for you. Before you get started programming, I want to talk about what I'll cover in this course. JavaScript is a programming language, and like any language, it has its own vocabulary and grammar. Programmers call this syntax. A programming language's syntax is the rules of the language, or the instructions, special words, and punctuation you use to put together a program. Every programming language has its own syntax, just as English, Spanish, and Mandarin each have their own vocabulary and grammar. I'll also teach you basic programming concepts. These concepts won't just apply to JavaScript. They're common ideas you'll find in other programming languages like Python, Java, or PHP. For example, variables, data types, and conditional statements. I'll teach you the concepts I think you should focus on at this particular part of your journey. And don't worry about remembering or fully understanding everything right away. This is a journey, and you're just getting started. As a programmer, it's also important to be able to talk like a programmer. So I'll introduce important vocabulary that's useful for you to know. These are programming terms that will come up often as you read, talk, and learn about JavaScript and programming, like the word syntax, which again is a programming language's vocabulary and grammar. Lastly, you'll learn important programming techniques. These are best practices or proven ways to put together programs so they work better. For example, you'll learn how to use comments to make your programs easier to understand and use. I'll also model for you the process of basic debugging techniques, or finding errors in your code. Making mistakes, sometimes mistakes that feel silly, are all part of the role of being a programmer, so it's important to practice finding and fixing those errors. Errors can often be your greatest teachers too. Learning alone can be challenging, but remember, you're not taking this course alone. There are many other students, some of whom are programming for the first time, taking this course right now. So I encourage you to make use of your support structure, like the amazing community and tools we offer to help you meet other students, ask questions, and talk about what you're learning. Also, with each video is a detailed set of teacher's notes. Now, I'll do my best to point out when there's something in there that you have to review, but try to get in the habit of checking the notes for additional resources, examples, and helpful tips.
Now you're going to take your first step into programming by creating a simple JavaScript program. A program is a set of instructions that perform specific tasks when executed by a computer. In other words, you're telling the computer what to do. To get started and code along with me, open your workspace and preview the index.html file in the browser by clicking the Preview Workspace icon. As you learned earlier, one of the benefits of programming with JavaScript and what makes JavaScript unique to other programming languages is that it runs in the browser. There's no need to set up any kind of development environment, which means you can start coding with JavaScript right away. As you learned earlier, there's a development tool built right into the browser called the JavaScript console, which you can use to run JavaScript code. Most browsers have a JavaScript console, but to follow along with me, I suggest that you use Chrome, since that's what I'll use in this course. You can open the console using the keyboard shortcut Command-Option-J on a Mac or Control-Shift-J on Windows. Or another quick way is to right or control-click anywhere in your browser window and choose Inspect. This will open up Chrome DevTools, which is a useful set of web developer tools to help you build websites and applications. You may have already used the Elements tab, for example, to inspect your HTML and CSS. Click Console to get to the JavaScript console. The console is often used to inspect the inner workings of your websites and applications. You can see messages logged from JavaScript or any errors that might be occurring. And as you experienced earlier, you can run JavaScript in the console to interact with the page you're inspecting. In the console, you can also run JavaScript that's not related to the page. Sometimes you just want to test some code or try out a certain JavaScript feature. The console is a perfect place for these kinds of experiments. For example, in the console, you can use JavaScript to perform basic math operations like 10 plus 5. Press Enter, and the console outputs the result of the math operation below your code, in this case, 15. If you type something in between quotation marks, like hello world, it will echo it back to you. By default, the console clears whenever you refresh the page. You can also click the Clear Console icon, or right or control-click anywhere in the console and select Clear Console. Now let's use a command called alert, which I showed you at the beginning of the course. Type the word alert in all lowercase into the console, followed by parentheses and a semicolon. Let's see what it does. Press Enter or Return to run this command in the console, and a dialog box pops up in the browser. It seems like something is missing in the dialog box. So let's try adding a message. And here's a shortcut. To bring back the previous command you ran in the console, press the up arrow key on your keyboard once. This lets you edit the command and run it again. This time, add a set of quotes inside the parentheses, and in between the quotes, type hello world. Press Enter again, and now there's a message. Alert is a command that's built into the browser. It opens a dialog box and displays a message. What we've typed here is called a JavaScript statement. A statement is like a sentence. And just as sentences end in a period, JavaScript statements end in a semicolon. You write programs by typing multiple statements, just like you write a paragraph by writing multiple sentences. Let's add another statement. Console.log is another widely used command that outputs a message to the console. Like alert, you can type the message between the parentheses. Within a set of quotes, write hello world. Console.log is going to log or print the message hello world to the console. Pressing Enter displays the message. This might not seem immediately interesting, but as we get farther along in the course and you do more programming, you'll start to see just how handy console.log can be. Here's another command, document.write. The word document represents the current web page, and write is a command that writes a message to the current web page. You'll learn more about why there's a dot between document and write, and between console and log, for example, later in this course. Now, let's provide a message to document.write between quotation marks. This time I'll type, welcome to my web page. Press Enter, and notice how it writes the message directly into the web page. Everything on the page is replaced by the message. This is not permanent though. Refreshing the page brings everything back. Document.write is not as widely used as some of the other techniques you'll learn to insert content into a web page, but you still might see it used in real-world projects, and it's a quick and simple way to let you produce some output while learning JavaScript, just like alert and even console.log. All right, you've learned 3 different ways to output messages with JavaScript: a dialog box, writing directly to the console, and writing to the current web page. Let's put these pieces together and write a small program using these 3 methods. If necessary, clear the console to add new code. First, type alert, and in between quotation marks, type the message hello, Thanks for visiting. Now, I don't want to run this code yet, so I'll press and hold down the Shift key, then press Enter to bring the cursor down to the next line without running the code. Next, type console.log and provide it the message, hello from the console, between quotation marks. I'll again press Shift Enter to bring the cursor down to the next line, and this time type document.write. And here's something interesting. You can even provide document.write markup or HTML tags containing the element and text to write to the page. H1 tags, for example. In between the H1 tags, I'll write the message, welcome to my webpage. And that's it. You can also copy these lines of code from the teacher's notes with this video. So now we have 3 lines of code, which we can run by pressing the Enter or Return key. First, the alert dialog displays. After clicking OK, the message appears in the console, and the welcome heading appears on the page. There are 2 things to understand from this. First, a program is a set of statements that run one after the other. Second, one statement needs to complete before the next statement runs. For example, the console.log command, which prints to the console, can't do its thing until the first alert command finishes. This also includes the user closing the dialog box. Once that happens, the console.log statement runs, and finally, document.write. Keep in mind that you won't often use alert or even document.write in your projects. I'm just using these commands now as quick and simple ways to produce some output as you learn the basics of the JavaScript language. You're also going to learn other common methods for running JavaScript and getting output when you're further along in your learning journey. All right, you've started your JavaScript programming adventure, written your first program, and learned new commands. In the next video, you'll learn where and how to add JavaScript to web pages.
The JavaScript console is great for experimenting with code and, as you'll soon learn, finding errors in your code. When writing larger, more complex applications, it's common to put your JavaScript code into a file that's separate from your HTML file, like you would with CSS, for example. So now I'll teach you how and where to link a JavaScript file to an HTML file.
Earlier, you learned that you can use JavaScript in lots of different places, for instance, on web servers and desktop applications. In this course, we'll concentrate on how JavaScript works in a browser. The browser is the most common place you'll encounter JavaScript and the easiest place to try out JavaScript programming. Browsers perform lots of different functions. They read and display content using HTML, they style that HTML following CSS rules, and they add behavior and interactivity to a page by following the instructions in a JavaScript program. Every browser has what's called a JavaScript engine built into it. It's a powerful part of the browser that reads, understands, and runs the instructions in a JavaScript program. When a browser encounters JavaScript programming, the JavaScript engine evaluates each statement in the program and does what the statement says to do. That is, your program runs as the JavaScript engine reads it. For example, earlier, when the browser read a statement with an alert command, a dialog box appeared on the screen. Here's some new vocabulary. When a browser reads and acts on a JavaScript program, we call that running the program. It's also called executing the program. So you'll often hear developers say things like, when the browser executes this line of code, a dialog box appears on the page. Browsers let you run JavaScript code from several different places. Most of the time, you'll write all your JavaScript code in a file that's separate from your HTML files. And there are 2 steps to writing and executing JavaScript from a file. You create a JavaScript file with a .js extension, then you link or connect the JavaScript file to an HTML file. Let's create a new JavaScript file inside the JS folder. In Workspaces, you add a new file by selecting File, New File. To create a new JavaScript file, provide a name followed by the .js extension. Script.js is just the name I want to give this file. A JavaScript file doesn't have to be named script.js. You can name the file anything you want. Let's add a line of code in this new file using the alert command. All right, we've created a JavaScript file and added a line of code. Now we need to link the file to our HTML. To link a .js file to an HTML file, you use the HTML script tag. Script has an attribute named source, just like the HTML image tag. The source attribute instructs the browser where to find the JavaScript file, and the browser then loads that file. Open the index.html file in the workspace and add a set of opening and closing script tags inside the head of the document. The script.js file is inside a directory named JS, so you can point to it by setting the source attribute's value to js/script.js, the name of the folder followed by the file name. This script.js file is now linked or connected to index.html, meaning index.html can run JavaScript code written inside the file. Saving both files and refreshing the browser displays the alert dialog. You can also add JavaScript directly inside the HTML by placing your JavaScript code inside a pair of script tags, like this. Within the script tags, I'll add an alert, displaying the text, another message from inside index.html. When I save my file and refresh the browser, notice how the alert in the linked file, script.js, runs first, and then the alert in the HTML file. That's because script.js appears in the HTML before the set of script tags. You can also run this code from the head of the document. For example, I'll cut the script tags out of the body and paste them below the first set of script tags. And notice how the browser runs each in the same order as before. Now, one thing you can't do is link to a JavaScript file using the source attribute and insert JavaScript code inside the same script tags, like this. Once you set a source, anything between the script tags gets ignored by the browser. So make sure that you have only one set of script tags per linked file and another set of script tags for any JavaScript you add directly inside your HTML file. And it's perfectly common and okay to have more than one set of script tags in an HTML file, like you see here. This is necessary if you want to link more than one JavaScript file to a page. Now, I didn't actually create or need an app.js file in this case, so I'll go ahead and delete this second script tag. Finally, you can place the script tag almost anywhere in an HTML file. You'll most commonly find script tags placed in either the head of the document, usually just before the closing head tag, or more often within the body, just before the closing body tag. One advantage of placing your script near the bottom of the page is that it lets the browser load and display the HTML before running the JavaScript. Notice what happens if I move this script tag to the bottom of the page just before the closing body tag. When I save this file and refresh the page, now the alert that's directly in the HTML loads first before anything else. Then the content of the page displays. Notice the headline. Then the alert from the script.js file appears. In this course, we'll use a separate JavaScript file and link it to near the bottom of the page just before the closing body tag, like this.
No developer is perfect. Even the most seasoned developer is bound to make coding mistakes. As you start programming, you'll find out really fast that it's easy to make a mistake. Like most developers, you'll probably make lots of mistakes. You'll find that most of the mistakes you'll make in the beginning will be simple typing errors, like leaving off a quote mark or mistyping a command like alert. These types of errors are common, but they're often hard to spot and could prevent your entire program from running. Finding and fixing problems is a big part of programming. Fortunately, Browsers provide tools that help you find mistakes so you can fix your programs. The most important is the JavaScript console, which, besides printing useful messages, lists any errors encountered by the JavaScript engine. So let's look at how you might identify and fix a problem in a JavaScript program. This error fixing skill will help assist you as you pick up the syntax of the language.
Let's force a few errors and then walk through the fixes together. Use your workspace to follow along. In the script.js file, start by typing alert with the text hello world. Next, console.log, providing it the message hello from the console. Right below, add an alert displaying thanks for visiting. And finally, use document.write to display an H1 with the text welcome to my webpage. I'll save my file and preview the workspace by clicking the preview icon. And notice how nothing's happening. An alert dialog is supposed to appear. This usually means that an error has occurred somewhere. Maybe the browser's JavaScript console can tell me why. I'll open the console to see if there are any error messages. Again, you can open the console with the keyboard shortcut Control-Shift-J on Windows or Command-Option-J on a Mac. And indeed, I see a bright red message in the console that says I have an uncaught syntax error. Remember, a program's syntax is its vocabulary and grammar, or a set of rules that define how we should structure the code. So a syntax error usually means that you type something incorrectly. The exact error is missing parentheses after argument list. This is a bit cryptic and not all that helpful because many things can cause this error. But there is one helpful piece of information on the right side of the console, which lets me know that the error is in the script.js file on line 1, where I've written the alert command. Remembering how alert works, you need to send it information inside quotation marks. Notice how there's only one quote mark at the end of the message. As you'll see later in this course, programming often involves pairs of punctuation marks, like an opening quote mark and a closing quote mark, or an opening parentheses and a closing parentheses. So adding another quotation mark at the beginning of the message should fix this. But something else is wrong. Not only should the alert dialog appear, there should also be a message printed to the console using console.log. We're seeing the same uncaught syntax error as before. Again, this usually means that you have a typo in your code. This time on line 2. Well, console.log requires an opening parentheses and a closing parentheses. Notice how it's missing the closing parentheses. Adding the missing parentheses should fix the error. There's the alert box and the console message. Now there's another error message letting us know that alert is not defined on line 3. Well, JavaScript is a case-sensitive language, which means that capitalization matters. You should always type its built-in commands and the keywords you'll learn about later exactly as required by JavaScript. Notice how on line 3, I typed alert with a capital A, change it to lowercase, and the alert now works as expected. There's one more error, this time an uncaught type error, something about document.write not being a function. You'll learn more about functions in a later course. For now, just know that both alert and document.write are functions. So something is wrong with the function on line 4. This time, it's a spelling error. The W in write is missing. Let me fix that and see if it works. And it does. One thing to keep in mind about syntax errors like this is that even if a program has many syntax errors, the console only shows you the first one, fix that, and then the console will show you the next one, fix that error, and you'll see the next syntax error listed, and so on. Even though making errors is normal and can often be a good thing, especially while learning, it still can feel a little overwhelming. This was a simple example, but when you have a bigger program that's 10, 20, or 100 lines of programming code, then you'll be glad that the console can point you to the exact line where errors occur. As you become more familiar with the rules and syntax of the language, you'll get better at avoiding spotting and resolving errors.
You've learned what JavaScript is, where it runs, and how to use some of its built-in commands. You've written JavaScript in the console, even created and linked a JavaScript file. Now you're going to work on a practice exercise on your own, a challenge of sorts. You'll do this periodically throughout the course to give you opportunities to practice and help make what you're learning stick. Let's go over what you'll need to do.
You're going to practice using JavaScript by writing a self-destructing message program. The page will display a message with an alert dialog warning us that the message will self-destruct. Then it displays a series of alerts that count down from 3 to 2 to 1. After that, the message on the page gets replaced by the text boom, and message destroyed appears in the console. Launch the workspace with this video to access the starter files for this challenge. In the file, script.js, you'll find the instructions for this practice challenge. The lines with the 2 backslashes in front of the text are JavaScript comments, and you'll learn more about writing comments in a later video. For now, just know that any characters immediately following the 2 backslashes until the end of the line are ignored by the JavaScript engine. You're going to use much of what you've learned so far to write this program, so let's go over the instructions. First, you'll need to display an alert dialog with the content warning this message will self-destruct in. Then display a 3, 2, 1 countdown as shown in the demo using alert dialog boxes. I've provided a line of JavaScript to help you complete the next step. You don't need to change this code or worry about what any of it means for now. As the comment says, this statement selects the h1 element on the page and replaces its text with boom. Soon you'll be a pro at working with JavaScript code like this, but don't worry about it for now. Finally, after the message self-destructs or gets replaced with the text boom, you'll need to display the text message destroyed in the console. I've already linked the script.js file to index.html, and feel free to customize the initial message displayed between the h1 heading tags. As you work through this practice challenge, keep in mind that you're not expected to remember everything right away. You can refer to any notes you've taken, code that you've written so far, or go back and review a video. This challenge is a great way to practice what you've learned so far. So good luck, have fun, and in the next video, I'll show you my solution. Hi, how'd it go? Hopefully you were able to complete all or most of this practice challenge successfully. If not, that's okay. Now I'll show you my solution, which you can also copy from the teacher's notes with this video. To create the self-destructing message program, I first used the alert command to pop up an alert dialog that displays the message warning this message will self-destruct in. The alert message, as you've learned, should be between quotation marks, and it doesn't matter for now if they're either single or double quotation marks. I use double quotes. Next, I displayed the 3, 2, 1 countdown using a series of 3 alert commands. The first alert displays 3, the second 2, and the third 1. The next part of the program includes a statement that selects the h1 element on the page and replaces its text content with boom. Again, you were not required to change this code or worry about what any of it means, but if you were curious and looked it up to learn more about it, that's great too. Finally, to display message destroyed in the console after the message self-destructs, I used the console.log command, and between quotes, I provided it the text message destroyed. All right, now that you've got some of the basics down, it's time to jump into a code challenge, then get into more complex programming. In the next stage, you'll learn how to store and keep track of different information in your program using variables. See you soon.
Printing a fixed value to the console or passing it to alert, like your name in quotes or the number 100, for example, isn't all that useful. Most of the time, a JavaScript program needs to work with information that changes. For instance, a social media site displays custom information to each user. A game shows a player's current score, and an online shopping cart includes all items selected by the user. A program needs a way of keeping track of all this information. Information that changes or varies each time a program runs is often stored in what's called a variable. Variables are one of the most important concepts in programming. A variable is a way of storing and keeping track of information in a program so that it can be later used and manipulated. For example, a computer game keeps track of a player's score. At the start of the game, the score is 0, but can go up if the player does well or down if the player makes a mistake. The game might even end if the player reaches a particular score. Score is an example of a variable. Although the score's value will change, 0 at the beginning, 100 at the end, for example, it's still always just one score for that player. Think of a variable as a box that you labeled with a unique name. You can put something inside the box, look inside the box to find out what's in it, you can empty the box, and even put something new in the box. While the contents of the box changes, it's still always the same box with the unique label you gave it. A program might need lots of variables to keep track of lots of information. In order for your program to follow all those variables, you'll need a way to identify each variable. That's why each variable has its own unique name, like score, which identifies that one variable.
Let's look at the syntax for creating a variable. You start with a special JavaScript word. This is called a keyword, and its name is var. Var is short for variable, and it creates the labeled box I mentioned earlier. We follow that with a space and a name for that variable. This is what's called declaring a variable. When you declare a variable with the var keyword, you can leave it empty. In that case, add a semicolon to the end of the statement, or you can create the variable and put something into it in a single statement. Using an equal sign, you can insert a value in a variable. The equal sign is called an assignment operator. It instructs the JavaScript engine to put whatever's on the right side into the name on the left side. In this example, put 0 into score. When you place something in a variable, it's called assigning a value to the variable. Now, let's declare and use a variable. To code along with me, launch the latest workspace with this video. In the JS folder, there's a file named var.js, and the script tag in index.html points to this file, which logs a message to the console. Again, var is just the name that I chose to use for this file. In var.js, let's use a variable with console.log. First, I'll use the var keyword to declare a new variable. This creates an empty variable named message. I'll talk more about naming variables in the next video, but in general, a variable's name should clearly describe what the variable will be used for. We can put something inside the variable or assign it a value using the equal sign. Here, I'm putting the word hello and an exclamation point inside the variable. You use quotes to indicate the actual letters, numbers, and symbols that you want to display in a message. A series of characters inside quotes like this is called a string. You'll learn more about strings later in this course. Once you store information in a variable, you can access and use its assigned value whenever you need it. To access the contents of the variable, you type its name. For example, replace the text hello from var.js inside console.log with the variable name, message. I'll save this file, preview index.html in the browser, and open the JavaScript console. Notice how the console prints message instead of hello. Because there are still quotation marks around message, we're telling the browser to log the word message, not the contents of the variable message. This is a quick fix. Remove the quotes. Save the file and refresh the page. Now, instead of seeing the word message, I see the contents stored inside the variable message. In this case, hello. In my program, the word message is now a reference to the value hello. So whenever I use message in the program, as long as I don't change its value, it will always mean hello. Variables are useful because you can change what's inside them. Let's change the contents of the message variable by adding another line of code and assigning it a new value. This time the message, hello from JavaScript Basics. This is called reassigning the variable. And notice that I'm not using the var keyword again. When you reassign a variable to a new value, you don't use var a second time. Only use it when you first create or declare the variable. The equal sign assigns a new string to the variable, which means that the initial value, hello, is gone. In other words, if I use the message variable anywhere below line 4, it's a reference to the value hello from JavaScript Basics and not hello. You can confirm this by adding another console.log below, like this. Save the file and refresh the page. This time, 2 different messages appear on the console. First, hello, then hello from JavaScript Basics. The exact same line of code, console.log message, produces 2 different results. That's part of the power of variables. Now, this is just one way to declare and work with variables. You'll learn other techniques later in this stage. Next, you'll learn about the rules for naming JavaScript variables.
Earlier, you learned how to create or declare variables. For example, use the var keyword followed by a variable name. But you can't just use any word for a variable name. There are a few rules you should keep in mind. First, JavaScript has a long list of reserved words. These are words that are part of the JavaScript language itself and are often called keywords. Var is an example of a reserved keyword. You can't create a variable named var, for instance.
In the browser, let's open up the console and see what happens if you try to create a variable named var. We get a syntax error. It says, uncaught syntax error, unexpected token, var. A token is usually one of those reserved keywords I just talked about. This error usually means there's something in the code that shouldn't be there, like an unexpected character, and the JavaScript engine doesn't know what to do with it, like a typo. In this case, it's not able to create a variable named var because var is a reserved word.
JavaScript has a long list of reserved words, which you will find in the lesson with this video, along with the other rules JavaScript has for naming variables. Now, don't worry about memorizing the full list. You might even want to bookmark this page for future reference. You've learned how to declare, name, and assign information or values to variables, as well as how to assign a new value to a variable. Remember, variables hold values that can change. Once you declare a variable and assign it a value, your program can manipulate what's stored in the variable as it runs, like a score in a game, for example.
You can use variables to do a variety of different things with the values stored in or assigned to them. Remember the variable score? It holds a number value. Let's say 0. Earlier, you learned that you can change what's inside a variable through reassignment, like this, score equals 10. Logging score to the console shows that the value of score is now 10. While we can change the value of a variable like score, we're overriding the value every time rather than keeping a running total of the score. Think about if you were programming a game and wanted to keep track of a player's score using the variable score. Well, instead of overriding the value of score each time a player scores points, you'd most likely want to keep adding to the total score. In other words, instead of completely replacing what's inside the labeled box with something else, we want to add to the current contents of the box. One way to add to the score is like this, score equals score plus 10. This might look a bit strange. The variable score appears twice in this statement. So how does this work? Remember, when putting a value into a variable, whatever's to the right of the equal sign goes into the variable on the left. In this case, what's on the right is the current contents of the variable score plus 10. The sum of the two values is placed back into the variable score. Since score currently equals 0, it's just like saying score equals 0 plus 10. The idea of accessing a variable to update a variable still might seem a bit strange, but it's really common in programming to update a variable based on the value it already has in it. In fact, it's so common that there's a shorthand method for adding to the contents of a variable. Replace this part here with a plus sign and an equal sign. This is called an addition assignment operator, and you'll see it a lot in JavaScript. To increase the score by a certain amount, you can use the addition assignment operator to add to its current value. For instance, score plus equals 5. Since the value of score was 10, I added 10 plus 5, and now score is 15. You can also add variables representing number values together. For example, declare a new variable named bonus points and assign it the value 100. I can add the current score value with the value of bonus points like this. Var final score equals score plus bonus points. We are adding the current value of the variable score plus the value of the variable bonus points and saving the sum of those values to a third variable, final score. Log final score to the console, and the result is 115.
For most of JavaScript's life, there's been only one way to create or declare a variable, the var keyword. Although many JavaScript programmers still use the var keyword, some of the behaviors of using var can be problematic or unexpected. For instance, a variable might accidentally get changed or overwritten with a different value further down in your program, which can be really difficult to catch. The JavaScript programming language gets updated regularly, and nowadays you'll see variables written using the keywords let or const, which let you put a value into them like you do with the var keyword, but they have different rules about how you use them and change their values in your program. So now I'll teach you how const and let work and demonstrate why you might want to use them instead of var when declaring variables.
Let and const work similarly to var. In each case, you use the keyword var, const, or let, followed by a name for the variable, an equal sign, and a value you want to put into the variable. We started with the var keyword since it's a little easier to remember that var means that something is a variable, and you'll still see the var keyword used to declare variables. But modern JavaScript development has shifted over to let and const because of their benefits. In many cases, they can make your code less error-prone. So what's the difference between var, let, and const? And when should you use one method over another? Well, we're not far enough into JavaScript to truly understand and benefit from the usefulness of let and const, but I'll teach you the basics of each, starting with the const keyword. In the JS folder, open the file named letconst.js. We'll now work in this file, so let's make sure to update the script tag and index.html so that it points to let-const.js. You don't need to write your variables in a separate file like this. It's just a new file we're using to learn about the let and const keywords. So const is often considered the best choice for declaring variables. Const is short for constant, meaning that the value of the variable should not change. It should remain constant. Const lets you protect the variable from being overwritten by any accidental or stray assignments in your code. In other words, once you create a constant and assign it a value, you can't assign it another value. Let me show you what I mean. Let's again declare a variable, or in this case, a constant called score, and assign it a value of 5. Then use console.log to display the value of score in the console. When I refresh the browser, I see 5 logged to the console, as expected. Earlier, you learned how to use the addition assignment operator to manipulate or add to the contents stored in a variable, like a score, for example. So let's try to add 5 to the score constant with score plus equals 5. This time, we get different results. There's an uncaught type error in the console that says assignment to constant variable. If there's one detail you should remember about using const, is that you cannot change or manipulate the value of a constant through reassignment. You're also not able to redeclare a constant. For example, redeclaring score and setting it to 5 produces the uncaught syntax error, identifier score has already been declared. The same happens if I redeclare using the var keyword. You'll use const variables frequently to store values that shouldn't change while the program runs, like product prices, a password, or username, for example. You can assign any value to a constant. In a later course, you'll, for instance, use constants to select elements of a web page. Imagine an application with hundreds or even thousands of lines of code that uses many variables that should not change. If you're declaring those variables with var, it could cause bugs that can be hard to find. For example, a score, product price, or username might unexpectedly get overwritten entirely. So the const keyword is one safeguard to prevent that from happening. For this reason, const should be your first choice when declaring variables. However, for a variable whose value should change while the program runs, constants are not the best choice. For example, you wouldn't use const to store the score of a game, since you know that the score needs to change as the player plays the game. In that case, use the let keyword when you want to reassign a variable. In that respect, let works just like var. So let's declare let score equals 5 and score plus equals 10. The console outputs the expected value, 15. The let keyword is almost the same as var. It lets you define a variable, but limits how you can use it. For example, let's say that later in your program, you redeclare a let variable, like let score equals 20. This produces an uncaught syntax error. It says identifier score has already been declared, whereas var would let you override the value in the initial assignment. For example, if I change each let to var, notice how the value of score is now 20. This behavior could produce bugs in your program because you might accidentally use the same variable twice. So let offers more protection and helps prevent you from doing that. There are other details and differences between let and const, which you're not required to know about yet, but you'll learn more about in later courses and workshops. Let and const will come in handy when you start working with functions, for example, and when you learn about something called scope, the area or context in which variables are accessible inside of your program. Since let and const are considered safer choices for declaring variables, I'm going to use them moving forward in place of var.
Let's take a moment to learn about space in your JavaScript programs. When I say space, I mean adding tabs, space characters, and line breaks to separate different parts of your code. JavaScript doesn't care too much about spaces. You can frequently leave out space or add spaces at the beginning of a line or between names and operators, like the equal sign when creating a variable. You can even spread a single JavaScript statement over multiple lines. But there are some standard spacing and indentation best practices that you can and should use to increase your code's readability. So this step provides examples of how you might use spaces, tabs, and new line characters to make your code easier to read and understand. Hey, welcome back. You've learned that in order for a JavaScript program to do anything, it must be given information to work with. In the previous section, you used variables to store and keep track of information that your program could use and manipulate. The information put into a variable is called a value. But what exactly are you storing with values? Values come in many different types, falling into categories called data types. All programming languages have built-in data types and treat each in a different way. Now at this point, you've used two JavaScript data types, strings and numbers. Numbers, or numeric data types, are used for making calculations, like adding, subtracting, computing total costs, keeping track of a game score, and so on. For example, a newsfeed application like Reddit might use numbers to calculate and keep track of how many upvotes a post receives. Strings are used for words, sentences, and other text in your program. You write a string as a series of letters, digits, and other characters inside single or double quotation marks. The characters are strung together. You've already seen strings in action when you used console.log and alert. You passed each a string. You'll use strings all the time when programming. And as you'll learn, there are several different ways you can create and work with strings.
To code along with me, launch the new workspace with this video and open the file strings.js, located inside the JS folder. I've also updated the script tag in index.html to point to this file. So each time you want to add a message to a web page, pop up an alert, or collect information from a web form, you're going to deal with strings. For example, when you wrote this statement earlier, the message in quotes, hello world, is called a string. Again, a string is a series of letters, numbers, and other characters inside quotation marks. All of these are examples of strings. A string can also contain HTML tags, like the h1 tags in the bottom string. The quotation marks around a string instruct the JavaScript engine that it should treat the contents inside as a regular set of characters. JavaScript lets you use either double or single quotes to create a string. You just need to be consistent. For example, if you begin a string with a double quote, you need to end the string with a double quote. Likewise, if you begin a string with a single quote, you need to end it with a single quote. Otherwise, JavaScript is going to produce a syntax error in both cases. For example, the console lets me know that there's an invalid or unexpected token. Now, things get a little tricky when you want to put a quote mark inside a string. For example, if you wanted to put "I'm a programmer" in a string, you need to be careful with the single quotation mark in "I'm." If you create the string using single quotes, you'll encounter a syntax error. Notice how the console lets me know that an unexpected identifier is causing the syntax error. The single quote starts the string, but the next single quote in "I'm" ends the string, at least according to the browser's JavaScript engine. So the rest of the characters are treated as if they're outside the string and therefore produce an error. Now, one solution is to use double quotes to create a string that has one or more single quotes inside it. Since the first quotation mark is a double quote, the JavaScript engine will not end the string until it finds the next double quotation mark. Likewise, you can use single quotes to create a string whenever you need double quotes inside a string. For example, if you want to put an HTML snippet inside a string, and the tag requires an attribute, which you normally write using double quotes, you'd write it like this. There's yet another way to put a quote into a string. You can use what's called an escape character. I'll change the message string back to single quotes. And if you include a backslash before the quotation mark inside the string, the JavaScript engine treats the quote mark like any other character. It's literally just a quote mark character at this point. Notice how it doesn't appear in the console output. You can use the backslash before either single or double quote marks. Finally, keep in mind that the JavaScript engine will also produce an error if you try to write a string on two or more lines like so. On the first line, I'll write "Hello, students." On the next line, "Welcome to JavaScript Basics." And on a third line, "I hope you learn a lot." Logging the value of the variable multiline produces a syntax error. It says invalid or unexpected token. Well, the JavaScript engine evaluates each line here separately. So according to the JavaScript engine, the first quote starts a string, but it doesn't have a closing quote mark. The second line is not wrapped in quotes at all. And the third line is missing the first quotation mark. So if you want to write a string on multiple lines, you need to escape any new line characters with a backslash. Adding a backslash at the end of each line tells the JavaScript engine that the string should continue to the next line. That way you avoid any errors. In a later video, you'll learn a more elegant way to create and work with strings with a feature called template literals. Up next, you'll learn ways to transform and manipulate strings.
There is so much power built into the JavaScript language. When you use a string, the JavaScript engine treats it as an object behind the scenes. Now, don't worry too much about the word object right now. Just know that because strings are treated as objects, JavaScript unlocks a slew of additional functionality you can use with strings, using what are called properties and methods. For example, you're able to transform a string by converting all of its characters to lowercase or uppercase. You can find the length of a string or the number of characters inside it, even combine several strings into one, and lots more. Let me teach you why this is useful.
In your workspace, open the file named transform.js located inside the JS folder, and let's update the script tag in index.html so that it points to transform.js. In JavaScript, strings are not only a type of data, they're also objects that have properties. For example, you can find the length of a string or the number of characters in it by looking at the string's length property. Let's declare a variable named passphrase and store a string value in it. You can find out how many characters are in this string by looking at the length property, like this, passphrase.length. Let's print this out to the console using console.log. The console prints the number 11. That's the number of characters in this string, including the space between open and sesame. I'll change the value of this variable to the word hi and see what happens. Now the console prints 2. You can use the length property for various programming tasks. For example, to make sure that a user set up a password that's at least 10 characters long but no longer than, say, 20, or to make sure that a required input field is not empty or has a length of 0. So now you may be wondering, what does the dot between the variable name and the length keyword mean? As you learned at the beginning of this video, strings are treated as what are called objects. So the string value stored in the passphrase variable is considered an object, and different types of objects have different properties. We'll talk a little more about objects throughout this course, but for now, just understand that you can access a property of an object using a dot. A property is kind of like a variable. It holds information. A string's length property, for example, contains a number, the number of characters inside the string. You can use the length property on any string, even a literal collection of characters inside quotes, like this. Because this string has 18 characters inside it, its length property is 18. Remove one character, and its length value changes to 17. Like a variable, a property is dynamic and can change. A method is something that you can do with the object, an action you can perform on a string, for example. JavaScript provides lots of different methods to use on strings. I'll start by teaching you 2 useful methods, 2 uppercase and 2 lowercase. You might be able to guess what each of these do just by their name. 2 uppercase takes a string and converts it to all uppercase letters, and 2 lowercase converts a string to all lowercase letters. Notice the parentheses at the end. The parentheses let you know that these are methods, like commands you can perform on a string. Back in my workspace, I'll change the string stored in the passphrase variable to something longer, like I have spoken, then convert it to all lowercase letters using the toLowercase method. Within console.log, I'll type the name of the variable, which holds the string value, a dot, and the method name, toLowercase. This is like earlier when we added a dot to access the length property. The main difference is that there are now a pair of parentheses, which again indicates that this is a method of the string. We're performing some action on it. In fact, you've already worked with other methods. Console.log, for example, is a method for the console. Save the file, and over in the console, notice how all the letters are now lowercase. including the I, the H, and the S. Keep in mind that the toLowerCase method doesn't change the original string or change the variable, in this case, the constant that's holding the string value. It only provides or returns to you a new string that's all lowercase letters. We can prove this by seeing what's inside the passphrase variable after the method runs. Notice how the variable passphrase isn't changed. Now let's look at the toUpperCase method, which does the opposite of toLowerCase. Change this to passphrase.toUpperCase. As you can see in the console, all letters are converted to uppercase. Good. Manipulating strings like this is a common and important JavaScript task, and it's frequently necessary when using JavaScript for user input validation or to deal with HTML text. You'll learn more about manipulating strings in a later video, where you'll use your newfound string manipulation knowledge to write a small program.
Earlier, you learned techniques for outputting information that you provided the program. For example, an alert dialog and printing a message to the JavaScript console with console.log. So far, it's been just you manually feeding the program input, which isn't all too useful. Just about every application that you interact with provides ways for its user to give it information. For example, sign up for an account, log in, create a profile, and so on. You can capture dynamic input from your site users in a number of different ways. For instance, when a user fills out a form field, you can capture what they type. Browsers also provide a simple way of capturing input with JavaScript. Let's see how it works.
All right, it's time to learn a new command. This time, open the prompt.js file inside your JS folder and update the script tag in index.html so that it points to prompt.js. The prompt command gives you a way to collect information from a site user. For example, you can ask a question and get a response. In your prompt.js file, start by typing prompt, immediately followed by a set of parentheses and a semicolon. Notice again the parentheses, which now you know means that this is a method. In fact, from now on, we can refer to these types of commands, including console.log and alert, as methods, which is what they're commonly called. You use the prompt method to ask a question or prompt the user to input some text. Like the alert method, you provided a message as a string. For example, what is your name? I'll save the file. When I refresh the browser, notice how prompt displays a dialog box with the question, much like the alert method, only this time there's a text field where a user can type something into it. I'll type Gil and click OK. But what happens to the text I just typed? As it turns out, the browser captures the user's response and gives it back to the program. In programming speak, we say that prompt returns a value. Knowing that, we can store that return value in a variable. In other words, we can capture the user's input to use in our program. For example, declare a const variable named name and assign it the prompt method. And now there are a couple of ways to see what gets stored in this new variable. First, we can use an alert. Back in the browser, I'll refresh the page, then type Gil into the dialog box. When I click OK, notice how Gil appears in the alert dialog. The prompt method gives you back the user's response or the text they entered. So notice how a variable is really useful in this case. By storing the name in a variable, each person who visits this web page gets a different response customized to them. You could also use console.log to write the variable to the console. I'll change alert to console.log. And while your site users probably won't look at the console, it's still a great place for you, the programmer, to send messages to yourself. You can use it to look into your program at any point. Here we're using the console to see what's inside the name variable at this point in the program. And we've been doing a lot of that so far in this course. For example, earlier we used the console to debug errors in our code, and we've also used it to check string and number values stored in variables. So as you learned, the prompt method provides a quick and easy way to capture user input, so it's a useful feature for learning. And later, you'll learn how to use information captured with prompt in a program. Although you might see prompt dialog boxes used on the web, in reality, you'd capture input using fields in a form. I'm not going to cover that in this course, but you'll learn how to capture input with forms in a later course.
JavaScript provides ways to combine two or more strings into a single string, and it's something you'll likely do a lot in programming. For example, you might collect a user's first name as one string and their last name as a separate string. To display the user's full name on the page, you'd need to combine the two strings. And what if you want to display their full name within a message? You'd have to combine the first and last name strings with a message string. There are different techniques for combining strings in JavaScript. First, I'll teach you how to add strings together using a process called concatenation.
String concatenation is the process of combining or adding two or more strings together to create a bigger string. One way to concatenate strings in JavaScript is with the plus operator. For example, by adding the string my favorite to the string movies, we end up with one longer string. In JavaScript, you'll often need a string to hold a value that you can't predict until your program runs. For example, if you want your program to greet someone by name, you might store the greeting hello in a variable. Well, you can't know the person's name ahead of time, so your program would need to combine the stored string hello with the person's name at the time the program collects that information, like when they log in, for example. Now that you've learned a method for collecting information from a user, I'll teach you how to use that input to create different messages. We'll do this by combining the string returned by the prompt method with another string. Open the file named combine.js inside your JS folder and update the script tag in index.html to point to combine.js. Let's start by declaring two variables, name and message. Name will store the value returned by a prompt dialog that asks, "What is your name?" Then assign the message variable a string that holds the word hello. Now let's add the name the visitor typed into the prompt dialog to this string to create a message like hello Gil or hello Anwar. Again, one way to combine or concatenate strings is with the plus operator, like this. Name holds the string returned by the prompt method. So notice how we're literally joining the two strings together with the plus symbol. Let's log the value of message to the console with console.log message. If I save the file and refresh the browser, the prompt dialog appears. I'll type my name, click OK, and see the message in the console. But notice that there's no space between hello and my name. When you combine strings, you're literally placing them next to each other. So if you need a space, you have to add it. I'll go back to my JavaScript file and add a space at the end of the string hello. I'll save the file, refresh the page, and that looks good. When a variable, like name, contains a string, adding that variable to another string is exactly the same as combining the two strings. In other words, the variable is really a placeholder for the string value stored inside it. You can add any number of strings together. For example, I can add another string to the message value, like so, period, space, welcome to my music site. Then a period and a space. I'll save the file, refresh the browser, enter my name, and the console displays the longer string. Hello, Gil, welcome to my music site. In programming, there might be times when you want to create a long string, maybe even an entire paragraph of text that includes string values from several variables. In that case, you can use the plus operator over and over, but doing that can often make your code hard to read. For example, I'll concatenate the string, "I'm so happy that you came by to visit," comma, space, then concatenate the string stored in the name variable, then concatenate another string that holds the text, period, space. Feel free to come again and listen to more music. I'll save the file, refresh the browser, enter my name, and there's the longer string. Hello, Gil. Welcome to my music site. I'm so happy that you came by to visit, Gil. Feel free to come again and listen to more music. Good. To make your code easier to read, you can create a longer string using a series of smaller statements. For example, I can begin to rewrite this code like this. On the next line, type message equals message plus the string, I'm so happy that you came by to visit. Comma, space. This approach might look familiar. The variable message appears twice in this statement. Remember, when putting a value into a variable, whatever's to the right of the equal sign goes into the variable on the left. In this case, what's on the right is the current contents of the variable message added to the string, I'm so happy that you came by to visit. These two strings are combined, and then the result is placed back into the variable message. This works like earlier when we added more points to the current value of the score variable, for example. In this case, instead of completely replacing what's inside the box labeled message with something else, we're adding to the current contents of the box. And you learned that there's a shorthand for adding to the contents of a variable. Replace this part with a plus sign and an equal sign, or the addition assignment operator. Feel free to use whichever method you like, but plus equals does require a little less typing. Next, I'll build up the rest of the string like this. Message plus equals the string stored in the name variable. Then on the next line, message plus equals the string, period, space. Feel free to come again and listen to more music. Let's see how this works. I'll save the file and refresh the browser. Type my name into the prompt dialog, then click OK. In the console, we're not seeing the final message. Instead, there's some sort of uncaught type error. It says assignment to constant variable. Can you figure out what's producing this error? On this line, we're declaring the message variable using the keyword const. Remember, the value of a variable declared with const cannot be changed through reassignment. We're using the addition assignment operator to reassign message to a longer and longer string value until we have the final string. In this case, we need to use the keyword let, which, as you learned, lets you change or manipulate a variable's value through reassignment. Now let's try it. Refresh the page. I'll type Gil into the prompt dialog, and there's the final message in the console. Good. You've just learned some really important skills: how to add strings together using a process called concatenation, and how to combine strings with variables that contain string values.
So far, you've created and worked with strings using single and double quotes. You've also combined multiple strings and inserted dynamic information into them with variables using the addition or plus operator. Alternating between single and double quotes, concatenating variables with strings, and creating multi-line strings might seem like a messy and hard to read process for dealing with strings. You'll likely see similar techniques still used in real-life JavaScript code bases. But JavaScript now provides a more intuitive way to work with strings with a feature called template literals. Template literals not only make your code more usable and readable, they also enhance all the ways in which you can work with strings. Let's see how they work.
In your workspace, open the file named templatelyterals.js and update the script tag in index.html to point to template-literals.js. Writing template literals is almost the same as writing strings with single and double quotes. The most significant difference is that you define template literals with backticks instead of quotes. The backtick character is in the upper left-hand corner of the keyboard, and it shares a key with the tilde symbol. For example, all three of these evaluate to the exact same string. Let's recreate the hello message from earlier using a template literal. The variable name still holds the value a user types into the prompt dialog. Now let's change the value of the message variable to a template literal. Delete its value, then type 2 backticks and place the word hello inside them. There are a few additional bonuses and features that come with these backticks. First, instead of using the plus operator to combine one string with another string that's stored in a variable, you use a special placeholder syntax to insert a value into a string dynamically. A $sign with curly braces marks the dynamic values in a template literal. For example, I'll insert the value of name like this. This syntax might seem odd at first. Once you get used to it, though, it's a lot easier to read and work with than concatenated strings. I'll save the file and run it in the browser. And it works just like before. Whatever's inside the curly braces gets evaluated by the JavaScript engine and added to the string. This process is known as interpolation. You can put almost any JavaScript statement inside the curly braces too. For example, I'll do some math inside the template literal like this. It's $sign curly braces. Inside the curly braces, I'll type 2 times 3 o'clock. And let's see the result. The console displays the message, hello Gil, it's 6 o'clock. 2 times 3 evaluates to 6, so that's rendered inside the string. Another benefit of template literals is that you don't need to worry about spaces between words like you usually do with concatenation. You also don't have to worry about escaping single or double quotes or any characters at all. Now, the math was just an example, so I'll go ahead and delete it from my code. Now, let's continue with the rest of the message. Earlier, we used the addition assignment operator to reassign message to a longer and longer string value until we had the final string. That seemed tricky and a little hard to read, especially with all the string concatenation we had to do. In a template literal, what's great is that you write the value exactly as it's meant to be interpreted. Between the backticks, I'll include welcome to my music site, period. Then I'm happy that you came by to visit, comma, $sign curly braces. Then between the curly braces, insert the value of name. I'll follow that with a period. Then type, please come again and listen to more music. I'll save this, refresh the browser, then enter Gil into the prompt dialog, and there's the message. Another great feature of template literals is that they support multi-line strings. You can include 2 or more lines between the backticks without having to escape new lines, with a backslash, for example. Notice how the new lines are also preserved in the output. And that's it. As you can see, template literals offer a lot of conveniences when creating strings. They're easier to write and read. You're going to learn a whole lot more about working with template literals in future courses, workshops, and projects. You learned one way of collecting information from users by way of the prompt method, and you displayed that information in an alert dialog as well as in the console. While those techniques are great for learning, there are other effective options that tend to be a better fit when building projects. So now I'll teach you a more conventional way of displaying information on a web page using a special JavaScript method and property. You're also going to use many of the skills you learned in this stage to create your first web app. It's called Shout App, and here's how it works. When the page loads, a dialog box appears. The user types in something to shout, like JavaScript is the best. We'll convert their response to all uppercase letters, add exclamation marks, and display it on the page. This time, open the file shout.js inside your JS folder, and update the script tag in index.html to point to shout.js. First, declare a variable named string to shout to store the value returned by a prompt dialog that asks, "What do you want to shout?" Then create another variable named shout. We'll assign shout the return value of string to shout dot to uppercase. Remember, the to uppercase method converts a string to all uppercase. Next, I'll create the final shout message by declaring a variable named shout message and assigning it a template literal. Remember, you define a template literal with backticks. Inside the backticks, type the message to shout is colon, then use a $sign and curly braces to dynamically insert or interpolate the value of shout. Let's also add a couple of exclamation marks at the end. I'll test this code by logging the value of shout message to the console. In the browser, the prompt dialog appears. I'll type "I love JavaScript" as the text to shout. And in the console, I see the message to shout is "I love JavaScript" in all uppercase. Great. Now let's get this content into the page. I'll teach you a JavaScript method and property that will let you insert content, even HTML tags, into a web page. Inserting content into the page with JavaScript is a two-step process. First, you access or select the HTML element where you want the content to appear. Then you let JavaScript know what content to insert into that element. A common way to access HTML elements is with a method called query selector. Between the parentheses, you provide the tag name, class, or ID of the element you want to access as a string. So let's, for example, access the main element in our index.html file. To access the main element, we need to add one more piece of information before the query selector part, and that is document dot. Now, don't worry too much about what document dot means. In fact, you've seen it before when you use the document.write method. All you need to know right now is that query selector is a method of a built-in object the browser has called document. And it's what's going to let us interact with the browser to find the HTML element we want to access. You'll learn a whole lot more about this in a later course. Okay, so now we're saying, hey, JavaScript, go in the HTML and get us a main element so that we can do something with it. And it's going to return the first main element that it finds. In this case, there's only one. I can make sure that this works as expected by switching over to the console and running document.querySelector main. When I press enter, the console indeed returns the main HTML tag. Perfect. We've targeted the main element. Now we need to let it know what content to display. After the parentheses, add a dot, then type inner HTML, followed by an equal sign. Inner HTML is a property that replaces the existing contents of an element with new content. So what do we want the main element's inner HTML content to be? Well, in this case, it should be the value of shout message. And you learn that a string can also contain HTML tags. So let's make the message a level 2 heading by including opening and closing h2 tags inside the backticks. All right, let's try it. Save the file and refresh the browser. This time I'll type JavaScript is cool into the prompt dialog. Click OK and see the message appear on the page. And when I inspect the page in Chrome DevTools, notice the newly created h2 element that's inside the main element. Part of the code we use to build the Shout app might look familiar to you. You used it earlier as part of the self-destructing message challenge to display the final boom message, and in the very first video to replace the content of a web page with new content. So now you know how it all works. You've just learned some pretty powerful new tools and techniques in JavaScript. Interacting with web pages like this is a huge topic in web development, and you will continue to build this skill as you progress through your JavaScript curriculum. We have an entire course dedicated to interacting with web pages. As we wrap up this section on strings, I want to show you a resource where you can learn more about how strings work, as well as other string properties and methods. One of the best JavaScript resources is the Mozilla Developer Network, or MDN for short. You'll find that its JavaScript reference section offers in-depth information on every aspect of the JavaScript language. For example, the section on strings displays a sidebar that lists all the properties and methods you can use on a string. For example, here's the length property, which you learned about earlier. Below is the list of the methods. Again, one of the main differences between a property like length and a method is the pair of parentheses. The parentheses indicate that something is a command or a method of the string. Near the bottom of the list, we see the familiar methods 2 lowercase and 2 uppercase. Click on one, and it opens a reference page on the method with useful examples. If the title string.prototype.2 uppercase looks a bit scary, don't worry. The Mozilla Developer Network sometimes uses accurate but not beginner-friendly language to explain JavaScript, so a lot of it might seem like it's written for professional developers. For example, the string.prototype part here refers to the string itself, either a set of characters between quotes or a string value that you've stored in a variable, for example. So for now, know that the important part here is just 2 uppercase. With time and practice, you'll get more and more comfortable exploring a resource like MDN. I've also posted the links in the teacher's notes with this video.
We've covered a lot of material so far, and you've learned enough to start programming on your own. Now you're going to create a program that retrieves user feedback and combines that feedback to create a string that displays on the page. Along the way, you'll use most of the JavaScript concepts you learned so far. So let's go over what you'll need to do.
In this challenge, you're going to build a story maker program or word game, like the popular children's activity called Mad Libs. You'll ask for various types of words, like an adjective to describe something, a verb for action, or a noun. A person supplies words, but doesn't know how the words will be used. When they're done answering, the words are used to create a funny and silly story. Each time you load the page and the program asks questions, you'll get a new result. Launch the workspace with this video to access the starter code for this challenge. In the workspace, open the file named story.js, located inside the JS folder. This file is already linked to index.html, and it lists the instructions for this challenge as JavaScript comments. Let's go over what you'll need to do. First, declare variables and capture input. You'll need to use the prompt method to ask for a word. For example, one prompt asks for an adjective, another for a verb, then one for a noun, and so on. You'll store those inputs in a variable. For each word you ask for, you'll need to use a new variable. Then you'll combine the input with other words to create a message or story. You can use the plus operator to concatenate the user's responses into a longer sentence, or use a template literal. You can either use the example sentence you see in this demo, or you can create your own. Ask as many questions as you like and make your story as long as you'd like. The last step is to display the story on the page. Use the document.querySelector method and inner HTML property to display the final story inside the main element. You should display the final story as a paragraph between p tags. I recommend that you don't try to write this program all at once. For instance, don't start by trying to write every single line of code and then testing to see if you got it right. Good programmers break a program down into small parts. They build that part and make sure it works before continuing to the next part. There's a lot to do in this challenge, so I suggest that you start by creating a variable and storing input from the prompt method in it. You can test to make sure it works using console.log to log the value of the variable to the console. If that works, add another variable and capture another word. See if you can insert their values into a string or combine them with another string. Then print the result to the console and so on. Now, I've given you a lot to do, But this challenge is a great way to practice what you've learned so far. In the next video, I'll show you one solution to this challenge. Good luck. Hopefully you were able to complete the story making programming challenge. There was a lot to do, and even if you only got some of it to work, that's great. Now let me show you my solution, which you can reference in the teacher's notes and project files with this video. Remember, I suggested breaking down the program into small testable steps, so I'm not going to try to write the entire program all at once. In fact, I'm going to start at the end with my complete sentence as a paragraph element. Between the p tags, I'll type, "There once was a adjective programmer who wanted to use JavaScript to verb the noun." This is what I want the finished sentence to look like. I'll need to capture 3 words, an adjective, a verb, and a noun, and place those words into this string. I'll leave this string in the file for reference. Now, I'll add the first step to the program, capture user input and store it in a variable. I'll first ask for an adjective with const adjective equals prompt. Please type an adjective. And to make sure this works, I'll log the value of adjective to the console. I'll save this and test it in the browser. And it's looking good so far. Now I need to create 2 more variables. But before I do that, I'll try to make sure that I can get the value of the adjective variable into a string. I'll declare a variable named sentence to hold my final story sentence, then use backticks to set its value to a template literal. Inside the backticks, I'll include just the first part of this sentence. I'll use interpolation with a $sign and curly braces to insert the value of adjective into the final string. You could have also used string concatenation with the plus operator to achieve this. Next, I'll print the value of sentence to the console to make sure that it works. I'll save this and refresh the browser. In the console, I see that it works. Now I'll add 2 more variables up top. One stores a verb and the other a noun. Next, I'll add the rest of the sentence using string interpolation to insert the value of the verb and noun variables into the string. I'll test this in the browser. All the prompts appear, and the final sentence looks great in the console. Finally, I'll display the sentence on the page using the query selector method and inner HTML property you learned about earlier. The story should display inside the main element, so I need to provide main to the query selector method. Follow that with .inner HTML. And to display the HTML snippet stored in the sentence variable within the main element, add equals sentence. Now I'm ready to test the completed program. I'll save the file and refresh the browser. Type my 3 words. And everything works as expected. As you learned, the write one line and test it approach is really helpful and also great for catching mistakes. As you become better at programming, you'll be able to write more code before testing, but it's a good idea to write small, testable chunks of code before proceeding to the next part of the program.
So now you've built a basic program and practiced with variables, strings, console.log, and more. Well done! You've reached the end of another stage in your JavaScript journey. You're beginning to learn and use the building blocks that are present in just about every application. You might even start looking at websites and apps a little differently as you use them. In the next stage, you'll learn how to work with another core feature of JavaScript, making your program react to different situations using what are called conditional statements.
Earlier, you built a simple program that prompted the user for their name, then used a template literal to interpolate or build that name into a string. You may have noticed what happens if the user doesn't enter anything into the input field. For example, in the prompt dialog, I'll click OK without entering anything. When that happens, the final message looks a little strange. Notice the empty spaces where the name is supposed to display. Or what if the user enters a random string of numbers? Well, that doesn't make sense. Ideally, we'd check and make sure that the user entered correct information into the input field before displaying the hello message.
As a programmer, you'll often encounter times when your program has to react intelligently to input from a user. For our welcome message example, it would be a good idea to first check if the input supplied by the user is a string. If it is, then display the greeting. If it's not a string, then print out a message like, please type your name. That's just one example. There are many times in programming where you'll need to make a program behave differently based on conditions within the program. For example, in a spaceship battle game, if the player loses all of their ships, the game should end. Or if the player reaches 1,000 points, the game should get faster and more difficult. You can change what your program does by adding decision-making to it. Programmers can make a program react to different situations by using what are called conditional statements. A conditional statement can be as simple as, if this is true, then do that. For example, if the user types their name, then display a greeting. Or, in a space game, if the player is out of spaceships, then end the game.
You're going to create a conditional statement by building a quiz. You can follow along in Workspaces by launching the new workspace with this video. Open the file conditionals.js located inside your JS folder. The file is already linked to index.html. First, we'll ask a question and get a response from a user. Declare a variable named answer and assign it the prompt method, which asks, which planet is closest to the sun? Next, we'll add the basic structure for a conditional statement. Conditional statements begin with the if keyword, just like new variables begin with the const or let keyword. After if comes a set of parentheses. Inside the parentheses goes the condition. The condition is a test whose answer is either true or false. Then come a set of curly braces. Inside the braces, you put the code that runs only if the condition is true. The braces create what's called a code block that can hold one or more JavaScript statements. And notice that unlike most other statements you've learned so far, there is no semicolon at the end of a conditional statement. Now let's write the actual condition. Answer triple equals the string Mercury. This condition is a test. It asks if the value that's stored inside the variable named answer is equal to the string Mercury. In other words, did the user type the word Mercury into the input dialog box? The triple equal sign here is called a strict equality operator, and it's used to test if two values are exactly the same. In this case, it tests that two strings are strictly equal, which means that they have the same sequence of characters as well as the same length. If they are the same, then the condition is true, and the code inside the braces runs. To make the code easier to read, it's common practice to indent code that goes inside the braces, just like it's common in HTML to indent nested tags. Indenting the code makes it easy to see that the code block belongs inside the conditional statement. In this case, if the person answers the question correctly, then that's correct is logged to the console. All right, let's try it. I'll save this and preview index.html. I'll type Mercury as an answer. When I open the JavaScript console, I see that it works. Let's see what happens if I don't type the correct answer. I'll refresh the page, and this time type Venus. Nothing happens at all. This is the first time in our programming where code we've added to a program doesn't always run. Conditional statements let you control the flow of a program. That is, which code actually runs and when. In this example, when the condition is true, the program follows one path and prints "that's correct" to the console. However, if the answer is wrong, then it skips the console.log method. In either case, after the conditional statement, the program continues and runs any code that follows. You can also provide code that runs only if the condition is false. This is called an else clause. It's optional, but it's often used as a fallback for when a condition is not true. You add it to a conditional statement like this. The code you want to run if the condition is not true goes inside the pair of braces following the keyword else. The braces form another code block, and there is no semicolon after them either. It's best to indent code here as well, so you can see that it's part of the else clause. Inside this code block, I'll console.log, sorry, that's incorrect. Let's see what this does. I'll save the file, refresh the page, and submit an incorrect answer like Earth. And sorry, that's incorrect displays in the console. Type the correct answer, and you'll see that's correct. Good. So now there's one response if you type the correct answer, and one if you type the wrong answer. Only one message appears, and it's entirely dependent upon what happens here in the condition. Let's look at the basic structure of a conditional statement that includes an else clause. In programming, we call this an if-else statement. The two sets of braces create two code blocks. You can think of them as two doors, door number 1 and door number 2. With an if-else statement, you can only ever go through one of the two doors, never both. The condition, or what's inside the parentheses, determines which code the program will run or which door the program will enter. The condition is always either true or false. If it's true, then the program enters door number 1. If the condition is false, then it's door number 2. It's only one of the doors and only one code block that runs. Once the conditional statement is finished, the program continues. Finally, let's look at one problem with the quiz program. This time, I'll type Mercury in all lowercase letters. Notice what happened. The program thinks that I answered the question wrong, and strictly speaking, I did. To computers, a lowercase m is not the same as an uppercase M. So Mercury in all lowercase letters isn't equal to Mercury with an uppercase M. Fortunately, you can get around that using a string method you learned about earlier. The toUppercase method takes a string and converts all of the letters to uppercase. So you can apply that method to what the user typed like this. In this case, you also need to change the case of the string you're testing to all uppercase. Now, even if you type and submit Mercury in all lowercase, the condition passes, and "that's correct" displays in the console.
As you just learned, conditional statements let you make a program behave differently depending upon the circumstances in the program. The value a user types into a form, or the score in a game, for example, can change how the program runs. Conditional statements make your programs flexible and more interesting. Up next, you'll learn more about how to test for different conditions using comparison operators. In the previous video, you learned about an important programming concept, the conditional statement. You used a conditional statement to control the flow of a program. It made decisions and carried out actions accordingly, depending on different inputs. The most important part of a conditional statement is the condition itself. It's a test that checks to see if something is either true or false. For example, in this code, the condition is spaceships equals 0, which breaks down to a simple question. Is the value stored in the variable spaceships equal to 0? The answer is either yes or no. If the answer is yes, The game is over, and an alert dialog appears. As it turns out, all conditions, no matter how complex, end up with a simple yes or no answer, or as computers like to think of it, true or false. JavaScript provides lots of ways to test things. We've seen the triple equals operator, which is a way to test the equality of two things. You can use that operator to see if the value a user typed matches a particular string, or if the value in a variable is a particular number. JavaScript provides other comparison operators to help with conditional statements. Some of them you might already know from math. For example, the greater than and less than symbols are often used for comparing numeric values. For instance, you can make a game harder if a player's score is greater than 1,000. Or, on the other hand, if a visitor is less than a certain age, you could tell them to come back when they're older. To get some practice understanding conditions, let's look at a few examples.
In the JavaScript console, I'll start by typing a few conditions using the greater than and less than operators, and you try to decide if a condition is true or false. First, 3 is greater than 2. This is true because 3 is a larger number than 2. Next, 100 is greater than 100. This is false because the two values are the same. 100 isn't greater than itself. How about 100 is greater than or equal to 100? Well, this is true because although the value on the left isn't greater than the value on the right, it's still equal to it. Here's another one. Negative 12 is less than 0. And this is true because negative numbers are smaller than positive numbers, or 0. Okay, one more. The string apple is less than the string bear. The greater than and less than operators aren't limited to just numbers. In this case, the comparison is true because the first letter of the string on the left, the A in apple, comes before the first letter of the second string, the B in bear. That is, A comes before B in the alphabet. Also, in comparison checks, letter strings always come after number strings. For instance, if you check if a number string like 100 is less than a letter string like apple, a number is less than any letter, so this returns true. JavaScript provides two ways to test if values are equal: the double equal sign and the triple equal sign. The double equal sign is called the equality operator. It lets you test if two values are the same, but makes some allowances for different types of values. For example, 3 inside quotes is a string, and 3 without quotes is a number. But if you use the double equal sign, then the browser converts the string to a number before comparing them, and this returns true because the JavaScript engine converts the string to the number 3 and says that yes, the number 3 is the same as the second number 3. The triple equal sign is called a strict equality operator. It compares the type as well as the value. For example, a strict comparison like this is false because one value is a string and the other is a number. They are not the same type of value, so they are not equal. It might seem like using the double equals operator is better since it's more flexible. However, JavaScript developers tend to use the triple equals operator and avoid the double equals. Why? Well, you can get into some weird situations using the double equals operator. Here's one example. An empty string is equal to 0. This returns true. An empty string is equal to 0? Strange, isn't it? And you can learn why this happens in the teacher's notes with this video. But notice that if you use a strict equality operator, the result is false. In many cases, the two equality operators work the same, but there are a few cases, like the one I just showed you, where the double equal sign might get you in trouble. So for that reason, I'll use strict equality, or the triple equals operator, for the rest of this course. All right, now let's look at a few examples using the strict equality operator. 165 strictly equals 165.9. This is false, because the two numbers are not equal. How about the string Python strictly equals the string HTML? This is also false, because those strings have different letters in them. Whereas JavaScript strictly equals JavaScript is true, because those strings are exactly the same. But remember that JavaScript is case sensitive. So comparing JavaScript in all lowercase with JavaScript as it's normally written is false, because the first string has all lowercase letters and the second does not. A lowercase j isn't equal to an uppercase j. JavaScript also provides ways to test whether two values are not equal. There's the not equal or inequality operator. It's an exclamation mark followed by an equal sign. The exclamation point is called a logical not operator. So exclamation equals means not equal to. But keep in mind that it's better to use the strict inequality operator with two equal signs. For the same reasons, it's better to use the strict equality comparison operator. So let's look at a few examples of the strict inequality operator. First, 10 is not strictly equal to 9. This is true because 10 is not equal to 9. How about the string 10 is not strictly equal to the number 10? This is also true because the value on the left is a string and the value on the right is a number. So the two types do not match. Let's check if the string Java is not strictly equal to the string Java in all lowercase. And this is true because the uppercase j in the first string isn't the same as the lowercase j in the second string. Finally, negative 59 is not strictly equal to negative 59. Well, this is false because the two numbers are the same.
A condition in a conditional statement is really just a question with a yes or no answer. In JavaScript, we say that the condition evaluates to either true or false. True and false have a specific meaning in JavaScript. They're called Booleans, and along with strings and numbers, they represent a third type of value or data type in JavaScript. Though they have an unusual name, Booleans are simple. Remember, a Boolean value can be only one of two possible values, true or false. That's it. There will be times where you'll want to ask your program yes/no questions, then run different code based on those answers. Let's have a look at some examples.
This time, open the booleans.js file inside your JS folder and update the script tag in index.html so that it points to booleans.js. In JavaScript programming, the two possible Boolean values are represented by the keywords true and false. Because all conditions return a true or false value, you can see how these two keywords work by using them in this if-else statement. If I type true inside the condition and refresh the browser, the condition is true, displays in the console. Now, if I type false inside the condition is false appears. Notice that there are no quotation marks around the words true or false. They're not strings. They each represent a specific type of value, a Boolean value, so quotes should not go around them. You can assign a Boolean value to a variable, just like you can assign a string or a number to a variable. This is a common way to keep track of a certain condition throughout a program. For example, let's see how we can use a Boolean value in a number guessing game. First, declare a new variable using the let keyword named correct guess and set it to the Boolean value false. When the number guessing game begins, the player hasn't yet guessed anything, so we'll say that the guess is false. The value of this variable will only change if the player gets the correct answer. And notice how we're using the let keyword here because we expect the value of correct guess to change. Next, declare a variable named number to store the number to guess. You can set it to any number between 1 and 10. I'll set it to 6. Then let's declare one more variable named guess to store the answer the user types into a prompt dialog, which will instruct the user to guess a number between 1 and 10. Next, below the guess variable, let's write a conditional statement that changes the correct guess variable from false to true if the user guessed the correct number. Type if guess strictly equals number, run the code inside these curly braces, or code block. If the number the user typed into the prompt dialog exactly matches the number stored in the number variable, we're going to change the value of the correct guess variable from false to true. If the player guesses wrong, the variable isn't changed. It remains false. Now, there's one detail we need to address in the condition. You learn that the value returned by the prompt method is a string. So notice how in the condition, we are comparing a number value with a string value. For example, even if the user types 6, the program will compare the number 6 inside quotes with the actual number value 6. And this is always going to return false because we're using the strict equality operator, and the game will not work as expected. So for the sake of this example, we need to convert the string value returned by prompt to a number value. The quickest way to do this is by adding a plus symbol, or the unary plus operator, just before the guess variable, like this. Make sure that there is no space between the plus and the variable. So now this ensures that we're comparing two number values. It may seem a little strange, but don't worry too much about this operator for now. You're going to learn a whole lot more about converting strings to numbers and working with number values in a later course. For now, I've posted more information about the unary plus operator in the teacher's notes with this video. Finally, let's update the conditional statement below to check the current value of the correct guess variable and print a message that matches the condition. First, the if statement will check if the value of correct guess is true. If it's true, then log the message, you guessed the number. Else, if the value is false, then print a different message that reveals the random number. I'll use a template literal to insert the value of the number variable into the message, sorry, the number was $ curly braces, number. And that's it. Before running it, let's step through this code line by line. First, we declare a variable with the Boolean value false. Next, we store the number to guess in a variable named number. We then open a dialog box and ask the user to supply a number, which we store in the variable guess. Then the program tests the user's response. If the user supplied the same number stored in guess, then the correct guess variable changes to true. If the player didn't, however, then the variable stays the same. It's false. Then we have a second conditional statement that says, if the value in correct guess is true, then print a winning message to the console. However, if the value is false, then reveal the number. All right, let's see it in action. I'll save the file, refresh the browser. If I type, say, 8 into the prompt dialog, the console displays, sorry, the number was 6. Refresh the page to try again. This time I'll type 6 and see the message, you guessed the number. Good. You can also simplify the code in this if-else statement. Remember that all conditions are either true or false. That is, the test condition produces a Boolean value. Since we're already storing either true or false in the correct guess variable, we don't need to use the strict equality operator at all. In other words, this is the same as this. And as you can see, the number guessing game still works in the same way as before. There are other ways you might write this number guessing game without having to use two separate conditional statements. I used this approach to teach you how Booleans get evaluated and change the flow of a program when used in conditional statements.
So far, the conditional statements we've created provide just two possible paths. Let's call them door number 1 and door number 2. If a condition is true, like the user entered a name in an input field, the program passes through door number 1. But if the condition is false, then the program passes through door number 2. But what if you want many different outcomes, not just two? In our daily lives, we're used to many possible outcomes. For example, say it's your day off from work, and you're trying to figure out what to do for the day. Your first step might be to find out what the weather's like. Based on this, you could plan your day. For example, if it's hot and sunny, you might go swimming. If it's snowing, you might go sledding or skiing. If it's raining, you might stay in and read a book. You can't do all three, only one. And each choice is based on a series of conditions. If it's hot and sunny, if it's snowing, if it's raining. JavaScript also includes a way for a program to provide multiple outcomes using what's called an else-if clause.
All right, now let's open the else-if.js file inside the JS folder, and as usual, update the script tag in index.html so that it points to else-if.js. So else-if works like this. You start with an if statement, then add an else-if clause, which provides another condition to test. So now you have two conditions. If the first one is true, then the code in the first block between the first pair of braces runs. Let's call this door number 1. However, if the first condition is false, then we test a second condition. If the answer to that condition is true, then the code in the second code block runs. Let's call this door number 2. The second condition is not tested if the first condition is true. This is important. You'll only get to the second condition if the first is false. Now, if neither of the conditions is true, you might want to provide a fallback, door number 3, so that the program does something. You can do this by adding an else clause to the end. Notice how there is no condition for this last part. However, the code block at the end only ever runs if both of the conditions above are false. And there's no limit to the number of else-if clauses you can add. But remember that you must start with an if statement, and the else clause, if there is one, must go at the end. So now there's 3 test conditions and 4 possible outcomes. And keep in mind that as soon as one test condition is true, the code for that condition runs, and all the conditions following, including the very last else clause, are skipped. Now let's see how you might use this conditional statement in a program. Earlier, I gave some examples of activities you can do based on weather conditions. For instance, if it's snowing, you could go sledding. Your first step might be to find out what the weather is like. Based on that, you could plan your day. In the first condition, I'll check if weather strictly equals the string sun. If it's sun, log the message, it's sunny, so I'm going swimming. In the else-if clause, I can check if weather strictly equals rain. And if it's rain, log it's raining, so I will read a book. I'll have the next else-if clause check if weather strictly equals snow. And if so, then log the message, it's snowing, so I'm going sledding. Now, the else block at the end only ever runs if all 3 of these conditions are false. In that case, log the message, I don't know what I'm doing today. Before testing this code, I need to declare the weather variable and assign it either sun, rain, or snow. I'll try rain first. I'll save my code. And over in the console, since weather is equal to rain, I see the message, it's raining, so I will read a book. I'll try sun, then snow. And it works. Now, if I change the value of weather to an empty string or anything other than rain, sun, or snow, for example, the console prints, I don't know what I'm doing today. So as you've learned, an else-if clause provides a way to make a program more flexible and able to respond to multiple conditional outcomes.
Sometimes a single condition isn't enough to make a decision. For example, even if it's a hot day, you don't want to go swimming if you don't know how to swim. In this case, you might ask, if it's a hot day and I know how to swim, then I'll go swimming. There are two tests here. Is it a hot day and do I know how to swim? In order to move on to the action, going swimming, they both have to be true. If the first condition is false, for example, it's not a hot day, then no action is taken. If the second condition is false, I don't know how to swim, it doesn't matter if it's a hot day, I won't be going swimming. JavaScript has a special operator to test more than one condition. It's called an AND operator and is represented by two ampersands. You place one condition on either side of the two ampersands. The two conditions are evaluated separately, but work together to create a single Boolean value, true or false.
For example, let's say you want to test if a variable holds a number between 20 and 30. Well, there's no single comparison operator you can use to check if a number lies within a specific range. However, you can use the logical AND operator for this. I'll demonstrate using the JavaScript console. You can follow along too if you'd like. In the console, I'll declare a variable named age and set it to 25. I can test the value in this variable like this. What we really have here are two separate conditions. 20 is less than age, and age is less than 30. Each condition is tested separately and produces its own true or false value. We know that the value in the age variable is 25, so the first test asks if 20 is less than age. In other words, is 20 less than 25? Yes, it is, so this first condition is true. The second test asks if age is less than 30. Is 25 less than 30? Yes, it is, so this condition is also true. The role of the logical AND operator is to combine the two tests. It asks, is condition 1 true and is condition 2 true? In this case, yes, they are both true. So when I run this by pressing enter, you can see that the result is a true value. Let's continue with a few more examples. I'll change the value of the age variable to 35. Then press the up arrow key twice to bring back the conditions. Now, the first condition is true because 20 is less than 35, but the second condition, 35 is less than 30, is false. So notice how the entire condition evaluates to false. All right, how about I set the value of age to 10? Now the first condition is false, and the second condition is true because 10 is less than 30. But it doesn't matter. Since just one of these is false, the entire condition evaluates to false. Finally, let's say there's a string value in the variable. Well, that isn't a number at all, so it can't be compared to a number. In this case, both tests are false, and logically enough, the entire condition evaluates to false.
As you can see, the AND operator is pretty strict. Use the AND operator whenever you need two conditions to pass before starting an action. For example, say you have a login form on your website. You might check to see that both the username and password fields are filled out before submitting the form. If both the username and password fields are empty, then don't submit the form. You learn to use the AND operator to perform an action if two or more conditions evaluate to true. There are times you'll want to perform an action if either of two possible conditions are true. For example, if it's hot or the indoor pool is open, then I'll go swimming. In this case, either condition can be true. It might be really cold outside, but the indoor pool is heated and warm, so I'll go swimming. On the other hand, the indoor pool may be closed, but it's hot, so I'll go swimming in the ocean. To run this type of test, you use the OR operator. It's called OR because the entire condition returns true if either condition 1 or condition 2 evaluates to true.
The logical OR operator is represented by two pipe characters. On most keyboards, the pipe character is on the same key as the backslash. Hold down the Shift key to type it. All right, let's see how the OR operator works. Say you let someone agree to the terms and service of your website by typing either yes or just the letter Y. They can type either one or the other. Back in the console, I'll store the response in a variable named agree and assign it the string yes. I can then use the logical OR operator like this. Agree strictly equals yes, or agree strictly equals Y. Just like with the logical AND operator, there's really two separate conditions here. Each condition gets tested separately and produces its own true or false values. The value in the agree variable is yes, so the first test asks if yes is strictly equal to yes, it is, so this first condition is true. The second test asks if yes is strictly equal to Y. This is not true. The role of the OR operator here is to ask if condition 1 is true or condition 2 true. In this case, 1 is true, and that's enough to make this entire condition evaluate to true. Let's continue with 2 more examples. I'll change the value in agree to just Y. Now the first condition is false. Y is not equal to yes. But the second condition, Y is equal to Y, is true. So the entire condition is also true. Remember, just the one test needs to pass. What if I set the value of agree to N? The first condition is false, and the second condition is also false. In this case, because neither condition is true, the whole condition evaluates to false. Keep in mind that you need to create complete conditions on either side of the OR operator. For example, you can't do something like this. Even though it feels like this should be correct, it really reads like if agree is equal to yes or Y. Whatever appears on either side of the OR operator has to be a complete condition. Y by itself isn't really a condition. So remember, you need to have full conditions on either side. In the logical and OR operator examples, I've used just 2 conditions and a single logical operator. You can actually have more than one of each operator. For example, you can test if condition 1 is true, and condition 2, and condition 3, and so on. There's no limit to the number of logical AND operators you string together. Just remember that with the AND operator, every single condition must be true for the entire condition to evaluate to true. If just one of the conditions is false, then the entire condition is false. You can also string together multiple logical OR operators. In this case, only one of the conditions needs to be true for the entire larger condition to evaluate to true. In this example, if any of these 3 variables contains an empty string, then the entire condition is true.
It's a lot of fun to program, but it's not always fun to return to a program you wrote 6 months or a year ago. Looking at an old program sometimes feels like you're reading a foreign language. It's easy to forget why you programmed something the way you did. Your code is not just for the JavaScript engine to interpret. You should also consider other developers who might read and work with your code. Fortunately, JavaScript provides a way to leave messages in your code that can help explain what's happening in a program. When you or another developer look at your code later, these messages or comments can quickly help describe what's going on in the program. You can add comments anywhere in your JavaScript code. They're ignored by a web browser and don't affect how your program works. Where should you put comments? Well, it's a good idea to add comments to identify different sections of code. For example, to introduce a long conditional statement, or to explain particularly complex blocks of code. Comments not only help you, but also anyone else who works with your code.
JavaScript provides 2 different types of comments: single-line comments and multi-line comments. Single-line comments are represented by 2 forward slashes. Everything following the slashes until the end of the line is ignored by the browser. If you want to add a long message to your code, you can use a multi-line comment, which begins with a forward slash and asterisk. Anything following those 2 characters, even carriage returns and multiple lines, are ignored by the JavaScript engine until it encounters a final asterisk and forward slash. I'll teach you how to use JavaScript comments by documenting the number guessing game you wrote in the file booleans.js. First, I'll add a multi-line comment that explains what the program does. The number guessing game
stores a number between 1 and 10, and gives the player one attempt to guess the number. It's common to add a multi-line comment like this to the beginning of a JavaScript file. This is a place where many programmers put copyright notices and author information. Now, I'll add a single-line comment that says, when the game begins, the guess is false. Developers usually include the comment directly above the code they're commenting on. In this case, I'm explaining what the next line of programming does. Now, you don't need to comment every line of your code. For example, the next two lines are pretty straightforward. This line stores a number in a variable, and the next line opens a prompt dialog and stores the user's input in a variable. You also might add a comment that explains a piece of code. For example, the next part of this program is the first conditional statement. So you might add a multi-line comment to explain or outline what it does. First, test if a player's guess matches the number. Then change the value of correct guess to true if they match. I'll add one last comment to explain what happens in the final conditional statement. Test if guess is correct and output response. Finally, there are a couple of other ways you might see comments used. For example, you can use single-line comments to annotate small specific snippets of your code like this. These are also referred to as inline comments, since they're related only to the line they're written on. Now, too many of these comments can make your code harder to read, so you should use them sparingly. Finally, you can use comments to disable code and prevent it from running. For example, comment out a line of code like this. Now the JavaScript engine is not going to run this line because it's commented out. Using comments like this can be helpful when debugging. Just make sure not to leave snippets of commented out code in your final script. So as you've learned, adding comments to your code is not only helpful for you, but also anyone else who needs to see your code in the future. So get in the habit of using them. You've learned a lot about JavaScript so far: variables, strings, numbers, and conditional statements. In fact, you've learned enough to put together complete programs. So let's wrap this course up with a little simulation that will produce a working program that utilizes most of your newfound JavaScript knowledge. For this exercise, I want you to write a simple quiz application. Let's have a look at what you'll need to do. Launch the new workspace with this video to access the starter files for this challenge. Open the quiz.js file located inside the JS folder. This is where you'll write all your code, and the file is already linked to index.html. I've provided the instructions for this challenge as JavaScript comments, so let's go over the tasks your application needs to perform. The quiz app should ask at least 5 questions. You'll store the answer to each question in a variable. It also needs to keep track of the number of questions the user answered correctly using a variable. And here's a hint. The addition assignment operator can help you with this. For example, if a user provides the correct answer, use reassignment to assign the current number of correct answers plus 1 to the variable you declare here in step 1. Then it needs to rank the player. If the player answered all 5 questions correctly, give that player a gold crown. 3 to 4 is a silver crown, 1 to 2 correct answers is a bronze crown, and 0 correct is no crown at all. Keep track of the ranking with the variable you declare here in step 2. Finally, the app should show a final message on the page after the quiz, letting the user know the number of questions they got right and their ranking. You can display the ranking below or next to the number of correct answers, for instance. Notice how you're asked to select the main element in index.html. This is where you'll display the final message.
The goal is to get your quiz app to work similar to this. In the next video, I'll show you how I would program this challenge. Good luck and have fun. Hi, how'd you do in this challenge? There are many different ways you could have built the quiz app. Now let me show you how I did it, using only the concepts covered in this course. First, I declared a variable to hold the number of correct answers. I set this to 0 because at the start of the quiz, 0 questions have been answered. As someone takes the quiz, I'll add 1 to this variable for each question answered correctly. That's why I used the let keyword instead of const. At the end of the quiz, the total number of correct answers gets stored in this variable. Next, I declared a variable named rank to store the final ranking of a player, for example, gold, silver, bronze, or no crown. I didn't assign it a value yet because later I'm going to put a string value in it based on how many questions the player got correct. In this case, since I know that the value will be a string, I also could have assigned rank an empty string like this. To display the final message and player ranking inside the main element, I used the document.querySelector method to access the main element and stored it in the variable main. The next part of the program asks 5 questions using the prompt method. I declared 5 different variables to hold the answers and ask different questions. Asking a question and testing the response is really the heart of the program, so I needed a way to test if a response is correct. I used the toUpperCase method to convert the user's input to all uppercase letters, which lets the user get the answer correct, whether they type the answer using all lowercase, all uppercase, or any combination. The condition will evaluate to true. If the user provides the correct answer, the plus equals or addition assignment operator adds 1 to the current value of the correct variable. The next part of the quiz program determines the ranking. I used a conditional statement and comparison operators to assign a ranking based on how many questions the user got correct, or the final value of the correct variable. So first, if correct strictly equals 5, assign the string gold to the rank variable. Then I ran a second condition with an else if clause. Remember, a player gets a silver crown for 3 or 4 correct answers. So notice here that I'm checking to see if the value in the correct variable is greater than or equal to 3. Now you might be wondering if this first condition will also evaluate to true if the number of correct answers is 5, since 5 is greater than 3. Well, it won't, and here's why. Remember that an if-else statement only runs one code block. Even though there may be multiple doors or conditions, the program only ever goes through one. In this case, the first if statement at the top strictly tests for 5. So that means if the correct variable has the number 5, the program enters this block, runs its code, which assigns a value to rank, and then exits. In other words, if the player answers 5 questions correctly, the program never gets to this else if condition. Next, I tested for the bronze crown using the condition correct is greater than or equal to 2. And with the final else clause, I assigned rank the string none. Finally, the next part outputs the results to the page. It lets the player know how many questions they got right and their ranking. The results should display inside the main element. The variable main stores a reference to the element, so I used the main variable and the inner HTML property to set the HTML markup inside main. Then I used a template literal with backticks to display the correct questions message inside an H2 and the ranking message inside paragraph tags. I'm using the $ and curly braces syntax or string interpolation to insert the final value of the correct and rank variables into the string. This is all very similar to how we displayed the shout message on the page in an earlier video, for example. All right, let's try this in the browser. I'll first try for 5 out of 5 correct. The page displays you got 5 out of 5 questions correct. Crown earned gold. Now let's see what happens if I get 0 correct. Again, there are other ways you could have solved this problem. This is just one solution. If your approach was different than mine, that's okay. And be sure to share your solution with other Treehouse students. There's so much you can learn from each other. Now, you may notice that some parts of this code do the same thing over and over, like asking the questions and assigning 1 to the current value of the correct variable, for example. While everything in the program works as expected, there's lots of room for improvement and ways to make the code more efficient and succinct. In a later course, you'll learn how to use JavaScript functions, which provide a more effective way to write and execute code that you want to repeat again and again.
Congratulations on reaching a major milestone in your JavaScript programming journey. Now, there's more to learn about JavaScript, and that's always going to be the case in programming. But at this point, you've learned the most important parts of JavaScript, the basic syntax and concepts you'll use just about every day as a JavaScript programmer. If you didn't understand everything or feel like you can't remember everything I covered, that's okay, don't worry. In fact, most programmers don't remember everything either. It's common to head over to Google or a resource like Mozilla Developer Network frequently to get a refresher on how these features work. I've posted some of those resources for you in the teacher's notes with this video. Remember, we're always here to help, so if you have questions about anything covered in this course, feel free to reach out to other students in the community or the Treehouse staff. Thanks everyone, and happy coding.